Once again, good evening, one and all present over here for the first session of online FDP, whose inaugural program just now over here. To begin with first session, I would like to invite Dr. Ravindra Jilte sir, who is an associate professor working in Department of Energy Science and Engineering in Maulana Azad National Institute of Technology, Bhopal. Dr. Ravindra Jilte sir has received his PhD from IIT Bombay in year 2014 and MTech from IIT Madras in 2000. He's also he's into academic from last 24 years. Dr. Jilche is carrying out collaborative research with several international universities and has published many of his novel work in a highly referred journal, based on which his names has been features in Elsewhere Standard University, USA World's top 2% scientists published in year 2022, 23, 24, and 2025. He has 35 plus Q1 journal listed SCI publications to his credit in last 6 years from 2018 to 2024. These publications are based on international collaboration with researchers from more than 37 countries. His broad area of research is in design, development of various solar energy assisted energy systems and applications of computational fluid mechanics, fluid dynamics, which is called as CFD in energy systems. He has conducted CFD study on solar thermal applications like characterizations of heat losses from compact fractional linear reflector in the solar thermal power plant, parabolic dish activity receivers used in the process heat application. He has exhibited research expertise in enhancement of heat transfer and cooling of thermal systems by using nanofluids, phase changes material, etc. He has published 70 plus Scopus SCI research papers in highly referred international journals and conferences with cumulative SCI impact factor more than 250 plus. He has conducted CFD study of solar thermal applications like the characterizations of heat losses from compact fractional linear reflectors used in the solar thermal power plant, paraboloid disk cavity receivers used in the process of heat applications. He has also worked in CFD simulations on an innovative battery thermal management system for electrical vehicles and hybrid electrical vehicles. Dr. Jilte is currently running one funded project of rupees 35 lakh from ANRF, Government of India, on development of field testing of solar integrated portable mobile milk chiller with latent storage system. He has contributed as a resource persons for various faculty development programs. He has delivered expert talk on modeling advances in BTMS of electrical vehicles and hands-on session solar flux ray tracing using Soltrace software for online faculty development program on next generation sensor monitoring and automation of energy systems and electrical vehicle. Organized by E and ICT Academy in association with the Department of Mechanical Engineering, NIT Patna. Sponsored by Ministry of Electronics and Information Technology, Government of India. Dr. Ravindra Jilte has delivered distinguished speakers talk at faculty development programs titled Sustainable Energy Spectrum, Exploring Trends and Applications in Renewable Resources in the Army Institute of Technology, Pune. Now I hereby invite and request to Dr. Ravindra Jilte sir to start this session.
Thank you, sir, for your nice introduction of mine. The slide is visible?
Yes, sir. Yes, sir.
With due respect to Lord Buddha, Bodhisattva Dr. Bhimrao Ambedkar, the members of the management of the Institute, organizing committee members, and dear participant, I welcome you all for the first session on battery thermal management system for electrical vehicle. Before we start with the session, I would like to congratulate the organizing committee members for keeping the title which is the need of the hour. In the session, you'll understand and we'll try to find out what is our position as far as the research is concerned. And since the one of the aim of the FDP is to make aware of what is happening globally and how as a faculty members or as a citizen of the India or of a developing country, one can work together or one can work for the aim of making our India as a developed country. So here the title of the FDP, which also says about this global competitiveness, competitiveness, how we can achieve through this our research, our contribution while we are in the academia, while we are in the industry. Uh, I can assure you, after attending this session, few of the takeaway of the sessions will be toward this. So to begin with the title, although the title of the session is about battery thermal management system for electric vehicle, let us look at the heart of the electric vehicle. We all are driven, or I mean, we all are known the terms called as IC engine driven vehicles, where IC engine called as a heart. Here also, if you look at the main components of an electric vehicle, here it is the major component which is available or which is installed in the entire car to drive the to give the propulsion is the traction factory pack. So EV battery is rechargeable energy storage that supplies power to the electric motor very quickly and giving EVs high performance and rapid acceleration. So this is the very paramount part of the electric car. In addition to the battery pack which is fitted, we have the so many components that works together to in a car. Like we require the power inverter that will try to convert from DC, sorry, from on the battery into alternating currents, and then this alternating current is used by the electric motor. We do have in a battery the other components called as controller, which takes and regulates the electrical energy from batteries to the inverter. We do have the other component which exactly replaced by the IC engine. So like the system will be driven by the electric motor, and the power to the electric motor will be given by the battery. So here the electric traction motors are available, which converts the electrical energy into the mechanical energy, that is the rotation. This rotation of the motor rotates the transmission so that the wheels turn and then the car moves. In addition to that, we have the so many components are available, like the charger is there for facilitating the charging of the EVs, the transmissions are there, then the DC and DC converters are there. So before we delve into the topic of battery thermal managements, in market and in automobile industry, we have so many options of electric vehicles. Let us first try to understand what types of electric vehicles are there in market. Like if you talked about the 100% battery operated electric vehicles, we normally that is called as battery electric vehicle, wherein you will have the battery pack which supplies the energy to the electric motor, and in turn electric motor will help us in driving or in providing the propulsion. This is the first one. So here the main components of this BEV are the electric motors which is fitted, inverter are there for conversion, battery, control modules and drivetrain. The examples wherein we'll find out this 100% of the battery electric vehicles are MG, ZS, Tata Nexon, Tata Tigor, Mahindra E20 Plus, Hyundai Kona, Mahindra Vertigo. Then we have in a market of automobile, that is electric vehicles, hybrid electric vehicles, where we in the car will find the engine is also there and the electric motor is also there. The engine gets energy from the fuel and motor gets electricity from the batteries. The transmission is rotated simultaneously by both engine and electric motor. This then drives the wheel. The main components in addition to the previous one is here. The fuel tank is now being fitted to supply the conventional fuel to the engine. Examples of the hybrid electric vehicles in the Indian market are few of the cars from the Marutis, few of the cars from the MG, few of the cars from the Honda Cities, Toyota, and the Lexus. Then we have the third categories of the electric vehicles. We call it as a plug-in hybrid electric vehicle, that is called as PHEV. In this case, it uses both IC engine and battery charge from the external socket. So they have the plug, therefore they call it as a plug-in hybrid electric vehicle. This means that the vehicle's battery can be charged with electricity rather than the engine. So PHEVs are more efficient than the hybrid electric vehicles, but less efficient than battery electric vehicles. So examples of the plugged-in hybrid electric vehicles are listed and displayed on the screen. So very high-end cars are there, like made from the BMWs or the Mini Coopers and the Mercedes, that basically employ the plug-in hybrid electric vehicles. Another initiative and another area which the government of India also has taken is called as the hydrogen car. Normally, we call this as the hydrogen car, but if you look at the internal accessories and internal components of the hydrogen car, we have the fuel cell. So fuel cell is there where the hydrogen will be used as a fuel and it turns into the electricity. That electricity will be fed it to the electric motor, or that electricity can fed it to the battery for storing of the energy storage. So these are the emerging kind of the cars are available. uh, the examples are very high end, like Toyota Vira is there, Hyundai Tuscan is there, Honda Clarity is there, Hyundai Nexo is there. So these are the few examples. If you now come to the topic which we call it as a battery thermal management of electric vehicles. So very first questions that comes to our mind is why we first discuss on classifications. We discuss on a classification because we wanted to understand what will be the size of the battery for each of these electric vehicles, and then how it gives us the challenges towards making or towards providing the cooling solution. So if you go through this particular slide, you can understand uh, on a y-axis there is a size of the fuel engine is there, and on a x-axis we have plotted the size of electric motor can also be related with the size of the battery systems. So for a conventional IC engines, we normally have a battery maybe of 12 volt or something. But if we go from a conventional IC engine to the 100% replacement of the IC engine, that is pure electric vehicle, then the size of the battery will be larger. So as the size of the battery will be larger for the pure electric vehicles, which will be little less in case of the medium hybrid, little less in case of the micro hybrid, because in case of the micro hybrid or in case of mild hybrid, there will be a contribution of the power generation from the IC engine. So there will be a lesser requirement of the energy from the battery side. But as we move on to the 100% of our power requirement taken from the batteries, the size of the battery will be more. Therefore, more challenges for providing thermal management solution exist for this electric vehicles. If you look at the exact requirement of the batteries for a different configuration, and if you just take out the one example of the battery EV, what we normally preferred, we preferred the battery which can provide the moderate power but very high energy. So we'll try to find out, there are so many types of the batteries are available. Therefore, the electrochemistry will also varies from one make to the another, and therefore the temperature which will be generated through the discharging operations or through the charging operations will also vary. As a result, there will be a different temperature development in the battery pack, and as a result we'll have to provide the separate battery solutions or the battery thermal management systems for a different electrochemistry cells. So here it is the case. Normally, as on the technology which are presently utilized by this automobile industries are lithium ion based battery in their vehicle. So if you look at the advantages of this lithium ion based battery systems, it has got the higher of the specific energy. Therefore, larger capacity of the energy can be kept per kg of the battery pack. Same thing, it will carry larger power per kg of the battery pack. So it has got both the advantage. Therefore, it meets as on at present all the requirement that is required to replace the conventional IC engine with the battery. Again, the topic which was chosen for this first session, we have seen many of the instances and the incidents of the explosion in electric vehicles. Whether it is two-wheelers are there, three-wheelers are there, or four-wheelers are there. The users, that is the consumer or the customer of the car, are not that much confident to use the electric vehicles after looking at the so many instances that is happening in terms of catching the fire in the electric vehicles. And surprisingly, when we try to analyze the situation, we have found out that the mostly the common culprit comes to the battery. So in our electric vehicle, we have the battery management systems. Through the battery management systems, it also runs the battery thermal management systems. So why this BTMS or battery thermal management system is important? First, what is BTMS? BTMS is essential in electric vehicles and energy storage systems. So BTMS is not only useful in case of the electric vehicles, it is also useful for many of the applications where, like for example, data centers are there. Like the example of the data center. Now you imagine the size of the backup which they provide at the data center and the size of the batteries they must be having in their data center and the kind of battery cooling solutions they need to operate the data center safely so that all the data will be at a safer locations and a safer place. So the battery thermal management systems not only useful in stationary applications, but also applicable in moving applications like electric vehicles. It regulates the temperatures of the batteries. It uses coolings and heating systems. Now here, normally in India, we have under the notions that we always provide the cooling of the batteries. But in many of the locations across the India, across the Europes or across the other countries also, where the temperature falls below 0 degrees Celsius, there will be a requirements of the heating systems to manage the battery thermal or to manage the safe operating temperatures of the battery. So these are the, I have just listed down the few of the points which will help us in understanding why the BTMS is important. Very first important point for us is the user confidence. Many of the locations, as I just now mentioned, that we want to build trust in a EV adoption. Government of India, through their all the programs, try to work on this aspect. And unless we, the researcher, we, the faculty members, we, the academicians, we, the persons from the industry, uh, help in one way or the other in making this EVs more safer for the user, that research or that kind of our contribution will be somewhere very helpful for the society. Like for example, few of the points like safety is there, so it will prevent the thermal runaway. A thermal runaway is the situation where one cell or one part of the battery pack catches fire. In a fraction of seconds, it will try to spread the fire in such a way that it will be impossible to come out of that vehicle. So we will try to avoid this situation, because many of the instances have reported where the drivers or the occupants of the car have not got enough of the time to escape from the car. Like, it will also help us in improving the performance, it will help us in improving the battery life. uh, Nowadays, the, the the development which is also happen in a mobile charger or mobile batteries, same thing happened with the EVs. We required a larger amount to be stored in a battery with a small or with a very small interval of the charging time, but it also gives us the challenges towards the cooling solutions, because when we try to charge the batteries in a very faster rate, the internal electrochemical reactions which is happening over there also generates the heat. So challenges are there in providing the solutions. Energy efficiency, as I mentioned, will be also be improving from this BTMS systems. Now let us look at this scenario. As I mentioned, this title and the title of the FDP, which the organizers and the management of the FDP has taken, we want to make researchers, academicians, and the industry persons and the industry in total to look at these aspects where we stand in front of the global. So now let us look at the actual facts over there here. If you, I've just taken the one source called as sciencedirect.com. If you try to type this battery thermal management of electric vehicles, you will find out, I mean, you can find around 30 to 33,192 articles are there on this topic. And if you just try to understand why this battery thermal management system is important, and why through this FDP, if you can create the interest, that will be the best part of this attending this FDP will be, if you can contribute towards emerging topic. For example, when this topic has started long back, initially, let us say 2016, only globally throughout the world, on this sciencedirect.com, we find only 820 articles are there. Over a period of time, this article has got increased contribution globally. And if you just look at the 2025, which has not yet completed, the number of articles has rose from 828 16 to 6,725. And if you look at the contribution which comes of this 33,000 articles, majority of the, I mean, what is happening in a global, let us understand, and then if we can change our perspective of looking at the research, looking at the our responsibility, and somewhere I will just try to note down here our position. Let us say the India here. Globally, majority of the academic institutions, the industry, and the researcher, they contribute on a research, active research. Therefore, they have contributed around 20,795 research article out of this 33,192. They have also wrote review articles, but that is very minimal. They have wrote something around 5,876 article as a review articles. If you look at the kind of publications they are targeting and the kind of publications we are targeting, we need to change our perspective. I mean, we need to change our mindset. Let us look at, they have published around 2,704 articles in a Journal of Energy Storage, which is Q1. Now, all of us at this point must be aware Q1 is top 25% of the journals. So, in that particular area, top 25% of the journal, they put it in a bracket called as Q1. So, there will be another categories of the journal called as Q2, where up to 50% of the top journals. So top 50% of the journals, they will put it in a second category called as Q2. Likewise, there will be a Q3 and there will be a Q4. So if you look at the number of articles that they have published, the energy is the journal which is also in the Q1. Applied energy is the topmost journals which we feel also in the Q1, and journal of power sources again is in the Q1. So globally, what is happening, and since the title of the FDP is to provide insights for the participants, global competitiveness, how it will be generated. It will be generated if we know the facts and the figures where we stand. So if you look at the same topic, when you try to search in a same platform called as Science Direct, and if you try to now filter out the articles where the authors belongs to the India, we find out that we have also contributed. Uh, we have contributed 2018 almost 60 the articles, and again from 2025 India has contributed around 859 articles. But surprisingly, what is happening, I mean, again, the aim of the FDP is to provide the insights. Research can happen and research can be done without much of the infrastructure. How it can be done, that will be discussed in a next slides, because many of the time we try to complain about facilities are not available in the academic institutes. The time is not available in the academic institutes. Infrastructure is not available, so therefore we are lagging in the research, or therefore we are lagging in the carrying out our research activity. But that is very partly to, I will disagree with the this kind of the statements and excuses given. We'll try to understand how this is possible. I mean, research can be done in a laptop. So all my research I have done in a laptop only. So let us try to understand how it can be done. But before that, let us look at the position of the India. So we have contributed research article of 1500, review articles in a comparable numbers 969. If you look at here, globally, academic institution, they target research. We in India target more or less review articles. This kind of trend or this kind of attitude is not helping us in making the our target of converting, or our target of seeing the developing country to the developed nation. What we want more and more research articles, more and more patents, more and more the our work towards research. If you again look at the publication title of this articles, Journal of Energy Storage, now we are targeting, let us Q1 is there. This is the review journal paper. Q1 is there, but we hardly contributes. And personally, I'm not in favor of publishing the review articles. This material today proceeding is the Scopus index. So aim of displaying this information is just to inspire you to take a research topic which the globally the researchers across the globe they are working. Now let us look at the our topic. battery thermal management systems. So here, if you look at the types of the battery thermal management systems or the classifications of the thermal management systems, we have very simple type of system which is called as air cooled. There is a pros and cons of this heating and cooling using air. Like if you look at the pros, all waste heat eventually has to go to the air. Separate cooling loop not required. uh, the air is available abundance in atmosphere. The weight is very less, or we can say the lighter. Lower cost is there, easier maintenance, no leakage concern. But if you look at the cons, if you look at the air as a working fluid to pick up the heat from the battery thermal management system, then the CP of the air, that is specific heat, is very less, let us say 1005 joule per kg Kelvin. So if the specific heat is very less, it will have lesser capacity to pick up the heat from the system. So what do you mean by this more temperature variation in a pack? We'll try to understand, but it creates unequal temperature variation. Uh, Parasitic power requirement is very high. We need to use the blower to circulate the air. Now let us look at the first options of air cooling. Very simpler way, you can take the battery pack. So let us try to understand the meaning of the battery pack. We have three types of the batteries are there. First battery, we can take it as a like the cylindrical batteries are available. Then we can have the prismatic kind of batteries are available. And the third type available is the coin battery or the pouch battery. So third battery is the pouch battery. Now, if you take the single battery, for example, if you take the 18650 type of battery, this is the cylindrical battery. Now, this battery can be available from different manufacturer. Like Samsung also manufacture this, LG also manufactures, and so many Panasonic is also available. So many manufacturers are available. What is this 18650 stands? 18 stands, the diameter of this battery will be 18 millimeter, and length or the height of the battery will be 65 millimeter. So single battery will not be sufficient enough to provide the power required in electric vehicles. So we'll try to connect large number of batteries together in a series and parallel connections to make the required capacity. That term is called as a battery pack. So battery pack inherently will have large number of the batteries, whether that batteries of cylindrical in nature or battery of prismatic in nature. In many of the electric vehicles, you will find out these are the two configuration. For example, Tesla, they adopt the cylindrical batteries, and the other manufacturer they try to adopt the prismatic battery. Now, we'll also try to understand what is meaning of the recirculated air cooling coupled with air condition. If you try to drive the electric vehicle in a situation where the ambient air is very hot, for example, the ambient air is 40 degree, or the ambient air is extreme summer condition like 45 degrees Celsius. In that situation, now this will be applicable. The situation is possible where the ambient temperature is, let us say, the 25 degrees Celsius, or the ambient temperature is, let us say, the 20 degrees Celsius. This is possible to take the intake of this ambient air, which is sufficiently at low temperature, pass it across the battery pack, and let it exhaust to the atmosphere. But if you happen to a situation, or if you try to design a battery thermal management system for a location or for extreme summer conditions where the temperature of ambient itself is very high, in that case, we'll try to utilize the conventional car AC, And in conventional car AC, you can find out the component called as evaporator. So you can utilize the air, you can cool down the air, and then chilled air or the cooled air, you can pass it to the battery pack. So at a first glance, this seems to be very simple. Let us try to now delve into the topic. If you try to look at this particular diagram, in a battery pack, you will have so many batteries are there. For example, I can arrange the batteries in this fashion. Inline arrangement of the batteries are there. Now, when you try to carry out the research on a battery pack, you have all the options of choosing the part or one subsystem of the battery. For example, in this case, in order to avoid the or in order to reduce the computational time, in order to reduce the simulation time, or in order to reduce the fabrications of entire battery pack, we can take a piece or part or subsystem of the battery and we can analyze. For example, here we have taken only the 9 batteries. We are kept in a inline arrangements. So we'll try to also understand what is meaning of the inline and the staggered arrangements. Now, if you look at this simple kind of arrangements, you must be looking at the diagrams. You may be in a suspicion that is it possible to work on this aspect and try to get a publication in a Q1 journal. So the idea of this session is that we'll try to analyze the situation, which will take it from a simpler case, and then we'll try to provide you the insights how to analyze or how to make a simpler case into the findings that can be published in a Q1 journal. So this kind of geometry, I took this geometry and tried to analyze the situation by taking only the 9 batteries. What I've done, we have simply tried to, let us say, the arrange the battery in a particular fashion, and indexing of the batteries is also done so that we can understand and we can find out the battery heat generation in each of this battery and how the accumulation of the heat takes place in and across the batteries. So as I mentioned that although it looks simpler, you need to find out the research gap. How to find out the research gaps? We can go through the articles that are based on air cooled BTMS systems. We have found out the research gaps, and it was possible for us to publish in a Q1 journal called as Engineering Science and Technology and International Journal, which is Q1 listed with the impact factor of 5.4. This publications we have done in a 2018. Uh, the major things which we required in this case and all other the research is that we need to find out the what is happening exactly in the air cooled existing BDMS systems. Air cooled battery module working at high discharge. So what is the new things that we have tried? We have tried the things called as uh, we investigated at a high galvanostatic discharge. Now the question will comes to our mind and which was also came to the reviewer's mind. What are the situations where this high galvanostatic discharge is required? For example, we are talking about the 7C. So C is the charging or discharging rate is there. For example, if it is the battery is there, and if you try to provide 1C, it means that the battery will be drained in 1 hour. If you try to discharge with a discharging rate of 2C, then the battery will be discharged in a half hour. If you try to discharge this battery with a charging rate of 0.5C, so battery can last for a 2 hour. So likewise, we have suggested and we have investigated in a situation what is the feasibility of adopting the air-cooled BTMS system for high galvanostatic discharge, that is constant current discharge. So the question where it, what will be the possibility of facing this kind of situation? So let us look at the pattern called as the driving pattern. We have to understand so many terms over here, like what is the driving pattern. We can design a electric vehicle for a smoother highway where the electric vehicle can move steadily with a uniform acceleration and deceleration. We can also look into the aspect that this electric vehicle sometimes in entire driving distance will also undergo the uphill. Now this is the uphill. In a uphill, the power which is required to withdraw from the batteries are very large. So for a, let us say this distance is very small, but the steep is very high. If the steep is very high, we require a larger power for a smaller duration. If it is the case, we'll try to withdraw more and more currents from the batteries. As a result, it will be turn it to the situation of either 6C, that is we are trying to withdraw 6 times of its rated currents or 7 times of rated currents. So we need to think of the operation of the EVs before we design the BTMS system. There are so many situations are there. For example, there is a sudden accelerations are there, braking systems are there, uphill is there, downhill is there, and so many driving patterns are available. So this can be easily justified. So here we try to understand. We wanted to understand and we wanted to provide the insights on what is meaning of transient thermal response. Transient means as per the time, what is the temperature development in a battery in a single cell, whether this cell is there, what will be the temperature development, or if this cell is there. Now if you look at over there, this cell that is 1, 4 and 7, it is facing the coolant air, whereas the cell which is located far away from the inlet will have a different air that is available for heat dissipation. So there will be a difference of the heat generation and heat dissipation for each of these cells. So that we wanted to study. We wanted to understand what are the temperature regimes are there, flow fields are there, and then cell to cell temperature non-uniformity and the location of the hotspots for the proper design of the BTM, that is battery thermal management systems. Since just now I mentioned that many of the times we, if you lack the infrastructure, the study can be conducted in a simulation way and it can be publishable as I mentioned. So what we have done, I have just done the meshing of this, that is modeling and simulation. Now this modeling and simulation, you can adopt any of the software. I adopted the ANSYS as a software, ANSYS CFD, for modeling and simulation of battery thermal management systems. So we can provide the mesh independent study. So very first thing which is required to publish and make it more acceptable to the global researcher is that we need to study the mesh independent study. What is meaning of the mesh independent study is that your solution is no longer depends on the kind of nodes. So let us, for example, if I try to take the same 9 batteries, and if I try to take the mesh where this 96,000 cells are available, or second one is if I increase 2 lakh, if I increase 3 lakh, or if I increase 7 lakhs, I found out that if I try to increase from 96 to the 3 lakh, and from 3 lakh to the double, like for example 7 lakh, the solution, that is the temperature developed in each of this battery or temperature developed inside this battery pack, remains independent of the grids. That situation is called as mesh independent study. So very first step which is required in a modeling and simulation kind of, or the CFD kind of studies, is to have one section in an entire article where you will be describing on the mesh independent study. We need to understand physically, there are two things. Physically, when we try to connect this battery and when we try to withdraw the current, at that time there will be some kind of electrochemical reactions. For example, in this battery there will be a electrochemical reaction. Now this electrochemical reactions will try to generate the heat. So if you have the physical kind of setups, you can attach the thermocouples over here and you can measure the temperature as well as the heat. But if it is the modeling and simulation kind of studies are there, then we need to adopt the battery heat generation model. So heat generation, battery heat generation model will help us in understanding the heat generated through the simulation. So let us try to understand. It comes from the two sources. One source is called as the entropic heating, which is happening, and other one is called as ohmic heating. Uh, if you look at the total heat generation in a battery, now all these equations we need to use when we try to find out the heat generation through the simulation. So there are two sources. One is the ohmic heating, also called as irreversible heat, which comes from the internal resistance of the cell. Like ionic is there, electronic is there, contact resistances are there. And the equation or the formula which is available is the I square R, where R is the internal resistance. We take it as always positive, causes heating in both charging as well as the discharging. For example, if you have the lithium ion cell, single cell with a current of 5 ampere, resistance is 20 milliohms, then we can find out the contribution of the ohmic heat is 0.5 volt. If you look at the second source is called as the entropic source, which is of reversible heat. It comes from the cathode and the anode part, where the electrochemical reactions occurring over there, and the expression which we need to utilize in the simulation is I, that is current is there, temperature is there, and the rate of del E by del T, which can be positive if you take it as a heating, which can be negative if you take it as a cooling. For example, if you take the single cell with a 5 ampere, temperature of in a cell is 300 Kelvin, then the slope which comes around minus 0.002 volt per Kelvin, and the entropic heat can be calculated as minus of 0.3 volt. Total heat, if you try to add this two, then it comes around 0.2 volt, 0.2 watt per cell. So this is the per cell. All these equations, if you earlier use the ANSYS CFD, then there is options of hooking of the UDF, that is user defined functions. So all these equations we can write down either C or C++ in a simple notepad. You can use any of the editor or the notepad. Then you try to compile it in a ANSYS CFD, and then this UDF will be available, that will help us in generating the heat during the simulation. Very second thing which normally we all of face is that since all our study we are doing on a laptop or any simulation, is it possible to get it accepted by the journals wherein they ask about the validation? So now look at this aspect also, uh, validation. If you look at this examples or this case studies which are taken, and look at the conventional heat transfer book. So if you refer the conventional heat transfer book, and that too if you refer any of the authored book, like for example if you refer the Inco Pereira is there or any of the author is there, you'll find out one topic is there that talks about the tube bank flow across the tube bank. That is the flow across the tube bank. Now if you visualize and if you can recall, through in your heat transfer course you have taught this concept to the students. Can we use this concept in carrying out the validation? In textbook they have given us the two kind of arrangements. One is called as the aligned arrangements or inline arrangements, and second one is the staggered arrangements. Exactly this situation matches with this situation. Now, theoretically, all the equations are available to predict the temperature across temperature, surface temperature, as well as the temperature across the tubes. We have also made use of this available literature, and we have carried out the validation of the CFD study. So what we have done, like for example, we have taken the two cases of passing the velocity, this velocity at a 0.1 meter per second, 0.5 meter per second, calculating the Reynolds number given in the textbook, and calculating the Nusselt number by the equation, then finding out the equivalent Nusselt number by the simulation. And we found out that through the equation, that is Incro-Pereira, 11.20 is the Nusselt number, and through the simulation it is the 11.16. In the second case, when the velocity is 0.5, the Nusselt number is 38.22. Here the Nusselt number is 38.34. So there is a very less percentage of deviation. So if you can try to figure it out and try to find out such kind of studies, such kind of conceptual things, theoretical things are available in a literature, and if you can make use of this literature to carry out the validation, the journals reviewers and the audience will try to accept this kind of validation. Then we try to display the cooling media temperature contours inside the battery module. So you can take out the uh, different planes. For example, here, like here, this is the case. We can take one plane from here, second plane from here, third plane from here. So horizontal plane can be taken, and then we can visualize what is the temperature that is happened develop inside the battery also, and in and around the battery, that is what is the air temperature that got developed in a system. So if you want to analyze the system, there is a two kind of analysis is there. One analysis we call it as a qualitative. So this is qualitative analysis, and the second analysis we call it as a quantitative. In case of the qualitative analysis, we try to provide the contours of the temperature, which is also displayed over here. And in case of the quantitative analysis, we try to extract the exact temperature data. For example, here we have taken one pathway in between the cells. For example, here we have taken one pathway from here, or one pathway from here, one pathway from here. For a sample display over here, I have taken this pathway between this cell in this flow direction. If you take the flow direction and if you try to extract the air temperature, so that will be somewhere here. How many points are there? Points are infinite. So many points are there. Can be thousands of the points available. So let us say the drawbacks or the limitations of the physical kind of situation. We can adapt physically maybe around 5 thermocouples. We may missed out the local heating because we cannot put hundreds of thermocouples. If you try to put hundreds of thermocouples over there, it will try to restrict and it will try to abstract the flow. But in simulation, the good thing about the simulation is that we can extract as many as points. It is as good as installing thousands of the thermocouples. So we have adapted this kind of technique, and we have recorded the temperature across this height, and this height, and we plot it air temperature distribution. Similarly, we have adapted one air distribution from this side, and from this. So if you look at this situation, we found out that the air temperature will be increasing and then the decreasing. So it is obvious. If you look at this color over there, air temperature is blue, which is minimal. Air temperature is maximum over here, which is behind the sail. If you look at behind the sail, the accumulation of the heat is there. Since the accumulation of heat is there, the hot air gets trapped over there. Therefore, the temperature will rise over there. And then if you look at this particular zone is there where the temperature is minimal because it has got the passage. So the minimal temperature is available in the passage. Minimal temperature is available in the passage, and the highest temperature is available behind the sail and behind the sail. So basic idea or the original idea of analyzing the location of the hot spot or the heat spot, we can visualize by extracting the temperature information from the simulation. This is what exactly we want. If you want to write good research articles, we need to dive deep into the research, deep into the concepts, and try to emerge or try to come up with the new understanding. So if you can come up with the new understanding through this deep research, the findings which you try to get it published, you will find out that it is possible to get it published in a given listed journals. So I will skip this portion. Now let us look at the convective air-cooled BTMS. Again, we observed for this case. I mean, this is all these things are as a part of the FDP. Let us try to first visualize the situation here and there, so that if you can observe any things that can be taken or that can be taken as a topic for the research or as a topic for the work to be carried out or work to be given to the students as a part of the projects, as part of the minor projects, or as a part of the PhD topic or the master topic. So this is the observation. if you take the number of batteries, definitely you will have some kind of the casing. You'll have the entry from one side, exit from the other side. So what exactly happens to the cells which is located centrally? For example, our understanding, air which is available at this location relatively at low temperature, it will pick up the heat from here. So its temperature is higher. If the its temperature is higher, when it approaches this cell, its temperature is already higher. It will pick up the heat from here. Again, when it approaches over here, its temperature is already higher. So it has got the lesser capacity to pick up the heat from third cell, lesser capacity to pick up the heat from fourth cell, fifth cell, sixth, seventh cell, and seventh cell. This is the drawback of arranging the batteries in this fashion. If you can modify this situation, so we tried to modify this situation, and we could publish this articles on this understanding in a journal called as Applied Thermal Engineering, which is Q1 listed. And if you look at the impact factor, it has got the 6.9. It was published in a year called as 2019. The slight modification what we adopted over there is, rather than passing the air in this fashion, again we have the all the options. Rather than studying the entire battery module, if, if the symmetry is there, you can utilize the symmetry. So we have only adapted this dotted zone, and that too the dotted zone looks like this. We modified this. We try to make it as a confined kind of arrangements where the air will be able to circulate in and around the cells. If you can guide the air to flow across in and around the cells, it will have the higher capacity and higher efficiency to pick up the heat. That was our main aim, or that was main objectives while we uh, modify this kind of arrangements. So we have obtained very positive results from this site, that is from the confined one, and therefore we have mentioned over there thermal performance of a novel confined flow lithium ion battery module. Since this arrangement is very novel, therefore we could write this word in a title, and it was got also accepted by the reviewers that novelty is there. So here also we listed down what are the different novelties in the very first year. These are the novelties. We need to attempt the issues which normally we find in this kind of situation, and entire aim of the paper will be to address these issues. So these are the results which is available for the air cooled. Now let us look at for the liquid cooled BTMS systems. There is again pros and cons of the systems are available. Like here, the very first advantage is that it has got the high values of the CP. That is the CP. If I use the water, then the CP is around 4187 joule per kg Kelvin, which is almost, let us say, the 4 times the air. So number of the advantages are there, but it has also got inherent kind of the cons, like the weight will be additional factors. Then leakage can be issues we need to address. High cost can be there. Then higher viscosity at cold temperature. Maintenance is on a higher side, and we require the additional components for the circulation of the liquids. Again, same thing, we can use the battery pack, we can circulate the liquid. That liquid can be get cooled with the air. Options are available: liquid cooling with the radiator, or liquid cooling coupled with the chiller. We have adapted the situation called as liquid cooling based BTMS. But now if you take the water as the working fluid or heat carrying fluid. In literature, you'll find out that if you try to refer the heat transfer literature, many of the researchers across the globe, they have adopted nanofluids. Either we call it as a nanofluid. So rather than using the base water, they try to utilize the nanofluid. We also thought that rather than using the liquid cooled systems, if you can adopt the nanofluids and then try to figure it out the findings. So here it is the case. The title which was given to the article was cooling performance of nanofluid submerged versus nanofluid circulated thermal management systems. Got published in a journal of cleaner production, which is having now present impact factor is 10, and again it is the key one journals. Again, my only sole aim of displaying this citation is to inspire you to carry the research which is of publishable in a key one journals. Earlier, we have mentioned that battery of cylindrical can be 18650 type, but we can use the battery of 26650, like 26 is the is the diameter, and length of the battery is 65 millimeter. Likewise, we have the another battery called as 42 millimeter and 120. These are the designations or nomenclatures of the batteries available in a available by the different manufacturers for its use in a for making the battery pack. Nanofluid can be made up of with the different nanoparticles. We adapted the alumina of 40 nanometer diameter nanoparticles. Now, this adoption of this size of the nanoparticles, adoptions of this alumina, all it depends on so many factors. For example, you wanted to first understand the compatibility of the alumina or the other nanoparticles. You wanted to first go through the literature findings from the other researchers. What is the best nanoparticles where you will find out the improved results, because nanoparticles and the nanofluids can also prove detrimental in producing the results. I mean, it improves the heat dissipation, but it also reduces the heat dissipation. So there is a contradictory kind of findings are available as long as the uses of nanofluids are there, nanoparticles are there. You need to first figure it out from the literature, from the available findings, what is the best nanoparticle size which can be taken. So we have used the nanofluids. Now, what we have done, we have simply utilized this arrangements. Since now this arrangement is available, and earlier we used the air as the cooling media. So we try to use the same configuration, except rather than air, we wanted to circulate the nanofluid. So here is the case, but we provided the two options. First options, if it is the liquid filled provision, that is, we have taken the casing, and in the casing, if you try to submerge the batteries, now there is no circulation of the batteries, liquid is there. All the cooling that is happen only with the air, which is in and around. In a second situation, we try to take a we try to take the second situation called as liquid circulated arrangements, where you have the provisions of in and out of the liquid throughout the passage. And then again, there is a question that if you air can be taken from the air condition, but what happens to the liquid? Suppose say I wanted to input the liquid with the temperature of 25 degrees Celsius. how will you get the 25 degrees Celsius of the water supply or the nanofluid? Then here it comes the role of the heat exchangers. We propose you have the air conditioners available in the car. We'll have the exhaust air which is coming out from the air conditioned car, which is at relatively low temperature than the ambient. Suppose say the ambient is 40 degrees Celsius. The air which is available from the vehicle will be relatively less temperature. So that can be utilized in heat exchangers, and we can cool down the liquid, and then that cool down liquid can be passed through the BTMS systems. This was the basic idea. So this is the novelty. Novelty of the study lies in the modular cooling with emphasis on cell-to-cell liquid cooling that facilitate cell-to-cell heat dissipation, avoid localized heat spot detrimental to the safe operating condition of specific cell. So results are displayed. We carried out the validation. Now the most important part is the validation. So sometimes we need to refer to the literature which is available, published in a good journals. We try to take the experimental findings, experimental photographs, what is happening inside, and similar kind of simulations. If you can provide a similar kind of results, say this is the results provided by present numerical scheme. This was taken by the photograph. Now this photograph is available in this. If you just look at there, through simulations, we can exactly try to obtain a result, like in terms of this also, in terms of this also. If you can provide this kind of validation, paper will be easily, or we can say it will have more chances of getting accepted for the given publication. Here also, when you try to provide the validation as per the experimental values, as per the numerical values, it exactly matches. So accuracy of the numerical scheme, accuracy of the numerical methods, and accuracy of the programs is very much important. The accuracy of the grids very much important in replicating or in duplicating the results. Then we have the third category is called as the PCM. So in case of the PCM cooling, we have the phase change material which picked up the heat from the battery, and later on we can dissipate the heat from the PCM to the ambient. So this is the third technique or the third classification. We also work on this aspect. If you provide the PCM material and if you embed the batteries in this situation, this is the one situation. So cooling will be only from this container side. Inside there will be accumulation of the heat in the PCM, and dissipation of the heat which is accumulated in the PCM occurs only in the boundary. So this can be seen as a drawback. If you can utilize the first design, then it is possible to create the passages wherein this blue is the PCM. PCM can be stored. Now each battery is surrounded by the phase change material. Since the thickness of this PCM is very less, the area which is available to dissipate its heat to the air, we can find out it has got the tremendous heat transfer area available for the dissipation compared with the first arrangement like this. Therefore, when we try to compare this results with this previous results, we could be able to publish these results again in a top journal called as Applied Thermal Engineering in 2019 with the impact factor of 6.9 as I mentioned. And the title which we picked up is Battery Thermal Management System Employing Phase Change Material with a cell-to-cell air cooling. What is the novelty? Novelty is we have provided cell-to-cell air cooling in a PCM systems. So there is so many the findings we provided over there. So I will not go much deep into the findings. We can easily scroll down the articles in a sciencedirect.com or any of the available platform, and you can delve into the insights. The accuracy of the numerical simulation, as I mentioned here, lies on the numerical schemes which we try to adopt. If it is possible to replicate, it is possible to obtain results as similar to the experimental one, chances of, as I mentioned, chances of getting it published is very high. Same thing we have done it with the PCM cooling. We found out that there is a experimental photographs are available. Like for example here, if you keep the solid PCM, if you keep the solid PCM, that is the experimental work, and if you try to heat this wall with the isothermal, that is, it is called as same temperature, so it is called as isothermal heating. We obtain that after a 10 minutes, there is a melting of the PCM occurs. Same thing we can also obtain through the simulation. If you look at there, the 0.05 means solid is there, and only this much portion get melted. If you again obtained, or if you look at and try to compare, after 20 minutes, the melted quantity of the PCM shown in a photograph by a black, through the simulation, we can also try to obtain the melted liquid fraction. Same thing after 40 minutes. So basic idea of showing again, once again, this slide is that try to find out similar kind of experimental studies which can be incorporated, utilized for the simulation. As I mentioned that all my publications, I have done it in a laptop. So physical installations of the infrastructure facility, if it is not at all there in your institute or in your premises, you can still take up the research and you can also contribute toward the research. We have also last 5 minutes, then I will take your questions. Last 5 minutes to wind up this session. Mm, the way we have taken the so many batteries are there, we can also think of taking a single battery and providing the cooling solution. For example, in this case, the article which we could publish in a 2023 in a journal called as International Journal of Heat and Mass Transfer. Again, Q1 journal is there. If a factor is 5.8, what we have done? We have taken a single battery cell. Like for example, let us say 18650 is the battery cell. Now, at this time, we understood that this diameter is 18 millimeter and this length is 65 millimeter. So what we have provided? We have provided helical channels. In helical channels, which is wrapping around the battery cell, we can allow the inlet of the nanofluid and the exit of the nanofluid on the other side. So options are available. You can analyze deeper and more deeper a single cell heat transfer, or you can take the examples of a multiple cells heat transfer. So like here, since the nanofluids are being utilized in this case, we call this as a hybrid nanoparticle enhanced phase change material. Now, two things we have utilized over here. One is nanofluid, that is liquid cooling is there. So let us look at the here. We have utilized the liquid cooling, and we have that is hybrid BTMS. So liquid is there and PCM is there. So liquid also utilized and phase change also utilized. So here, this dark is the lithium ion cell. The enclosure is a concentric kind of arrangements where the nano enhanced PCM is there, and surrounding to this we have made the helical channels where nanofluid can be circulated. So this kind of arrangements can be called as hybrid nanoparticle enhanced phase change material. So this is the case. We require the generation of the properties of the nanofluids. So in the literature, we will have the so many equations are available, uh, which can be utilized in making the density of the nanoparticles, specific heat of the nanoparticles, conductivity of the nanoparticles, viscosity of the nanoparticles, and the latent heat of the nanoparticles or the phase change materials. You try to utilize the different sources. You try to use the Excel sheet in generating these properties, and then this property will be fed it into the modeling and the simulation. Again, you try to extract as many as information about the temperature in terms of phase change material temperature variation across the battery, or melting fraction, that is how much is the portion of the phase change material get melted, or it is the battery temperature which will uh, gets changed as per the depth. Now the depth of discharge here we call it as a DOD. So DOD, if it is 0% is there, means 100% charge. So this is the 0%, 100% charge. If it is 100% charge, we call the depth of discharge is 0. If the depth of discharge is 30, it means that the charging now it is available is 70% and the discharge occurs is 30. So likewise, we could plot the PCM temperature variation for the base case, for the nano enhance without, this is WLC. Now this WLC stand for without liquid channels, this with liquid channels. So in one case, we have avoided this helical channels, and we in second case, I mean in first case we provided a simple PCM without liquid channels. In the second case, nano enhanced PCM with the liquid channels, and third case helical channels. So all possibilities are there. Briefly in the last 1 minute or fraction of seconds, I'll try to conclude. So likewise, just think of a situation, think of a uh, research gaps wherein you can carry out the ideas, you can generate the ideas. Like here, for example, we have provided, which was also published in the last year 2024 in a topmost journals called a Journal of Energy Storage, which has got the impact factor of 9.8. And here it is the liquid circulating pipes we have provided. So in a typical battery pack, we can have the 4 vertical channels, 3 horizontal channels. If you look at 1, 2, 3, 4 vertical, 1, 2, 3 horizontal. Likewise, you have the arrangements of a 6 vertical, 5 horizontal channels, 8 verticals, and 7 horizontal channels. Now all these channels will have the one inlet over here and the one outlet. One inlet is there and the one outlet is there. So all the options are available. Results are published, cell to cell temperature variations we publish. Then we also publish the variations of temperature non-uniformity. We also publish the how is the pressure drop that is happening over there, because we utilize the so many cells over there. Almost the 25 cells we have utilized over there. So significant pressure drop may occurs, which we try to minimize in this case of liquid circulated kind of systems. So these are the all the possibilities. So let us once again, so many classifications of the BTMS are available. Like we try to discuss on air cooled systems, the PCM cooled systems, the liquid cooled systems, and the liquid cooled PCM system, that is the hybrid systems. So we could only discuss the 4 or 5 types. As a researchers or as a the faculty members of the academic institutes or the industry, there are so many options are available to take the topic for your research. With this, I conclude my session. Thank you for your attentions. I'll take your queries now.
I request all the participants, if you have question, please raise your hand or unmute yourself and you can ask the question. Screen on अपनी screen. Chat करो. There's a question coming, sir, from Mr. Mayur Ritankar. Can we use BTMS in heavy duty vehicles?
Yeah, in my one of the slides, I have shown that the BTMS is utilized in all the kinds of vehicles, whether it is the two-wheelers, three-wheelers, cars are there, heavy trucks are there, or so many kind of the vehicles, whether it is heavy duty vehicles or commercial vehicles, light duty vehicles. So requirements of the size of the battery is different. Requirements of the battery cooling itself is very challenging. So my main aim of conducting this session is to make aware of there are so many opportunities are available as a part of this FDP. If I could enlighten and if I could encourage you to take up the topics which as per the topic of the FDP uh, to make our research global competitive. It's possible.
Okay, sir.
It can be utilized in heavy duty vehicles also.
Anybody from participant, please ask your question.
Hello, sir.
Yes, please speak. Yes.
Sir, my question was whatever analysis are done related to the battery management system or the cooling of the battery. So all these papers, whether they are CFD analysis or some type of experimentation can be carried out in this.
So whatever the studies and the papers or the case studies which are discussed and shown to you, all are generated through CFD. I mean, the main aim is many times we complain about the infrastructure facility is not available in the premises or in the institute or something. But there are opportunities to conduct simulation kind of studies. It's possible. It's quite possible. The only thing which is required is the strong validation of the scheme. If you can provide the strong validation of the scheme, that is numerical scheme, it can be publishable and it is acceptable by the global community, researchers, reviewers. If it is supplemented by the experimental validation, it is best. But if it is not there, still it is publishable.
Sir asking whether, hello. Sir, some of the participants are asking whether you are going to share the PPTs of this session.
Yeah, sure. I will be sharing the PPT.
Sir, you just share with you just share your PPT with my WhatsApp number, or
Sure.
otherwise the email of coordinator. Then we will share it on the participants group.
Yes, sir. This PPT will be available to all the dear participants to use it in any sense. I mean, they are free to use it, and if you can use it for their research uh, to further enhance their research, it is the best outcome of this FDP and the session.
Is it Rahul?
Yeah.
From participant, any question from participant?
Okay.
Okay,
Okay.
fine.
Okay, no any question from participants. I request Dr. Surya Munde to please deliver a vote of thanks of this session.
Thank you, sir. As we know, Albert Einstein said, energy cannot be created nor destroyed. It can be changed from one form to other form. Well, today I must say our resource person changed energy into the knowledge. Thank you. Thank you so much, sir. Such a nicely delivered and informative session.